phone call, it got cut. So again I'm continuing with the previous video. So here we'll take an example. So here to investigate this, consider an S-plane contour. This is an S-plane. This is S-plane sigma plus j omega. This is an S-plane contour. Okay, contour which encloses only one 0 of Q of S, which encloses only one zeros of Q of S here, that is say at S is equal to alpha 1, while all the poles and the remaining zeros are distributed in the S plane outside the contour. So here you can see alpha 2, alpha 3, these all are the zeros and this crosses all are poles. Remaining poles and zeros are distributed in the S plane outside the contour. Now, as we already discussed, for any non-singular point S in the S-plane contour, there corresponds a point Q of S on the Q of S plane contour. The point Q of S is given by Q of S, magnitude of Q of S is obtained by magnitude of S minus alpha 1, magnitude of S minus alpha 2, dot 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 divided by magnitude of S minus beta 1, magnitude of S minus beta 2, and angle of Q of S is equal to angle of S minus alpha 1 plus angle of S minus alpha 2. So it is related to zeros plus then minus of angle of S minus beta 1 minus of angle of S minus beta 2. This related to poles. Now here figure 8.2a, it is found that the contour found that as the point S follows a prescribed path, and you can see it is in clockwise direction on the S-plane contour, eventually returning to the starting point. From here it goes and it is coming back to this starting point. The phasor S minus alpha 1, the phasor S minus alpha 1, this is a S minus alpha 1. Okay, so phasor S minus alpha 1 generates a net angle of minus 2 pi. The phasor S minus alpha 1 generates a net angle of minus 2 pi because it is related to a 0. So minus 2 pi, while all other phases generate 0 net angle because it is outside the contour. Therefore, the Q of S phasor, so here you got a Q of S, the magnitude we found by these expressions and angle we found by this. So we put a phasor, Q of S phasor. Okay, this is the magnitude and this is the angle, this is the phasor. So the Q of S phasor undergoes a net phase change of minus 2 pi. So net phase change means minus 2 pi means it will go, this phasor will go in this directions and return back to this. That means you will get a contour. The contour shape, don't concentrate, it can be any shape, but it should, you have to check whether it is the contour contains the origin. That is only our concern. Therefore, the phasor angle was a net phase change of minus 2 pi. This implies that the tip of Q of S phasor must describe a closed contour about the origin of the Q of S plane. Tip of this describe a closed contour about the origin of the QoS plane in the clockwise direction because it is minus 2 pi. If it is plus 2 pi, it is in counterclockwise direction. In the clockwise direction. As said earlier, the exact shape of the closed contour in the QoS plane is not interest to us, but it is sufficient for us to observe that the contour encircles the origin once. So here you know that there are minus 2 pi, so this contour will rotate like this and come, and certainly this will come, the origin will come within this contour. That is our interest. The shape is not our interest, and the direction also clockwise directions. Okay, so this is very important. So only we are concerned about whether the origin is within the contour. So here the figure a S-plane contour enclosing S0, this is S-plane contour is S0, and corresponding Q of S and the corresponding QoS plane contour. So this is the corresponding QoS plane for this contour. And we already understood that yes. Now if the contour in this plane does not enclose any zero or pole, suppose if a contour in this plane does not enclose any zero or pole, the corresponding contour in the QoS plane corresponding this contour QoS plane then will not encircle the origin. If the contour in S-plane does not consist any pole or zero, then this contour will not encircle the origin. If S-plane contour encloses two zeros, say S is alpha 1 and S is alpha 2, the QoS plane contour encircles the origin twice in the clockwise directions. So here as you can see that this S-plane contour encircles two zeros, then the QoS plane, the contour encircles the origin two times. This is the first one time, then this is the second time. Okay, and the shape is not our concern, but whether it encloses, that is our concern. So here as you can see here, twice the clockwise directions, because when there is a zero, then the contour will be in the clockwise direction. It offers minus, for 1 0 minus 2 pi. If 2 0 means minus 4 pi. So the one will give one circle, another will give another this thing n circle. So here as you can see that, generalizing, we can say that each zero of Q of S enclosed by the S-plane contour, the corresponding QoS plane contour encircles the origin once in the clockwise direction. So for each zero of Q of S enclosed by the S-plane contour, each zero of Q of S enclosed by the S-plane contour, each zero of Q of S. This is the zero of Q of S. This is also zero of Q of S. So each zero of Q of S enclosed by the S-plane contour, the corresponding Q of S plane contour encircles the origin once in the clockwise. For each there will be one encircle. If 2 means 2 encircle, 3 means 3 encircle, like that. Now what happened if the S-plane contour encloses a pole at S is equal to beta 1? So the phasor S minus B2 generates an angle of, here also S minus B2 also generates an angle of minus 2 pi. Normally the pole is denominator 1 divided by 1 minus 1 divided by S minus alpha 1. So 1 by 2 pi. Since the pole term S minus beta 1 in the denominator of Q of S, the Q of S plane contour experience an angle change of plus 2 pi because it is denominator. S minus alpha 1 gives minus 2 pi, but 1 divided by S minus alpha 1 gives plus 2 pi. So these all things you have to understand like that only. Okay, we are not going in depth of that. Okay, plus 2 pi, which means one counterclockwise encirclement of the origin. So if there is a pole, there is a one. If there is a pole inside the, if there is a pole of Q of S inside the contour of S plane, then there is a encirclement in a counterclockwise directions. So counterclockwise encirclement of the origin. If the argument holds for all the poles of Q of S. So now if S plane contour encloses two poles, here you can see S plane contour encloses two poles of Q of S. Then you can see the corresponding QS plane contour. Here this is our it contains the contour will encircle the origin two times in a counterclockwise direction. See, it is in counterclockwise direction. If it is 0, it is in clockwise directions. If it is pole, it is in counterclockwise direction. This is only our concern. Don't worry about other all factors. Just understand this. That much is enough in this case. Now suppose if there are P poles and Z zeros of Q of S enclosed by the S plane contour. Suppose if you have a numerator and denominator, then if there are if there are P poles and Z zeros of Q of S enclosed by the contour of S plane, then you know that P poles means P encircles in the counterclockwise directions. Then Z zeros means Z clockwise encirclement. Now normally the number of poles is higher than nor equal to number of zeros. So it can higher or equal. So now you can see if in the case of P minus Z, so you know that net contour, how many contours are there? A net encirclement. How many net encirclements? If you want to understand that, you have to see P minus Z. That means suppose P minus Z. That means for a pole, it gives counterclockwise encirclement, and for zeros, for each zero, one clockwise encirclement. For each pole, one counterclockwise. So suppose how many one clockwise and counterclockwise will cancel. So how much encirclements are remained? In order to identify that, you have to see how many P minus Z. Suppose if there are 3 poles and 2 zeros, then you can see that P minus 2, 3 minus 2, 1 encirclement in QS plane in counterclockwise directions. So one encirclement means plus 2 pi. Now, for example, in case of 2 zeros and 4 poles enclosed by a S-plane contour, the net encirclement in the origin by the QS plane contour is 2 pi into 4 minus 2. 4 minus 2, 4 poles, 2 zeros, 2, and each one will give a 2 pi. Pole means plus 2 pi rotations, 0 means minus 2 pi rotations. So 4 pi radians. That means 2 counterclocks revolution. Okay, so for example, we will see that these are the 4 poles of Q of S, and these are the 2 zeros of Q of S, and a contour in S plane encircles 4 poles and 2 zeros of Q of S. Then what it representation in QS plane, that means U plus JV. You can see here is 4 poles minus 2 zeros. That means 2 encirclement. 2 circumference. Here number of poles are more, so it is in counterclockwise direction. 2 rotation, 2 counterclockwise encirclement. The shape we don't concentrate. It can be any shape, but it should encircle the origin. That's only our concern. So I think that you understood what I explained. This much only you need to understand.